everybody hear me? Yeah? Cool. My name is Jon Bellah. My talk today is on visual regression testing with PhantomCSS. I'll start out with a little bit about me. I'm a lead front-end engineer at a company called 10up. We're a distributed agency that focuses primarily on WordPress, doing WordPress for enterprise clients of all types. You can find me on Twitter at Jon Bellah. I want to start also with a disclaimer that the title of this talk may well be that visual regression testing with my personal favorite tool. There are a lot of options. Stacy talked earlier about Selenium. That is one of many. So there's Cactus, Huxley, Wraith, all these other different ones. I encourage you all to try them out before you dive into visual regression testing. You may like what I present with PhantomCSS, you may not. So it's definitely worth checking out some of the options that are available. So let's start with what the heck is visual regression testing. It's the automated testing of visual changes, as the name implies. This is basically what we're doing with PhantomCSS. Whenever you run a test, the first time you run it, you'll set a baseline. The baseline will then be what your future test runs are compared against. So you can see the second run there was the change, which also provided us with a diff. The diff is going to give you a highlighted version of what is different and show you where those changes occurred. So for example, if you're working on an article page and you change the font size there and you didn't QA the home page and missed a font size change that kind of breaks the layout, this will help you with that, and so might Stacy. One of the common things I hear when I start talking about visual regression testing and kind of CSS testing in general is, but I change CSS because I want things to look differently, and that's a valid critique of visual regression testing, but that's kind of not the point. So what is the point and why is it important? Oftentimes you find yourself, and especially in the work that I do, working with clients, we're iterating really quickly on some designs or some, a version 2 or something like that. So iterating on projects is important. Refactoring projects. So for example, if you inherit a client project that has old CSS in it and you really want to go and change them over to Sass, because CSS, the first letter in CSS stands for cascading, it means that order is definitely important. So if you're refactoring from CSS to Sass, you're kind of inherently going to change the order of some things as they're output into your CSS file, which is great, but it can also cause things to break. So if the CSS was poorly written, for example, and something is overwritten later in the file and you reorganize that, you could break the layout or the look of the site. Distributed projects is another example of something that that visual regression testing, easy for you to say, really helps with, because if you're working on a project with 5 or 6 other developers and a couple of them are front-end engineers, then you could possibly run into situations where someone else kind of breaks something you're working on right now, and that's not really good. So you can write a test suite that tests everything, and then everyone's kind of on the same page. Open source projects is another example where visual regression testing could be useful. Again, I said I work with WordPress a lot. WordPress itself is actually working on a pattern library / style guide that actually uses PhantomCSS to test the various different changes in WordPress. There have been thousands of contributors to WordPress over the course of the life of the project, and kind of expecting all of those people to really understand maybe the classes or things like that are used for buttons is difficult. So adding some testing to your project can really help there. It helps prevent unintended changes overall. Again, I use the example, if you're working on an article page, you change the font size and it breaks the home page. That's really unintended, and it kind of helps automate that process for you so you can work comfortably. And again, it automates your workflow. So a lot of people are using Grunt or Gulp or Broccoli or something like that to automate their workflow. A lot of people are using continuous integration servers like Jenkins or Circle CI or Travis CI. So you can actually integrate this with those tools. Manual testing is expensive. Every time you commit a change and you have to QA 20 different pages, that takes time and money. It's imperfect. A lot of people are going to miss a lot of changes. You could, the padding changes on a button and you kind of don't see it. But I have excellent attention to detail. Actually, humans are really terrible at spotting changes. I don't know if you've worked on a project for 2 or 3 or 4 months. You get to this point where you just stop seeing the differences anymore. You start kind of really focusing on what you're doing, and you stop noticing the things that are kind of ancillary and happening off to the side, things that you could affect with your code. Here's a little video that kind of illustrates my point. It was made by the London Underground, and it's obviously not intended to illustrate the point for web developers, but it does a really good job of kind of hammering that point home. So see if you can spot all of the changes here.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away. It's just a matter of observation. The real question is, how observed were you? Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts and precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Well, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
I'm guessing you missed a lot of those, because I did. So this actually is a phenomenon that's been studied a lot. Studies kind of go back to the 70s, but the kind of foundational study that happened was by a couple of scientists named McConkey and Curry that did a study at the University of Illinois in 1996 that they coined the term change blindness, which means that which is a perceptual phenomenon that occurs when changes in a visual stimulus are made without someone noticing. So to say that you have great attention to detail, we just kind of prove that that's not the case. And they've done a lot of studies about this, and it's not really targeted at us as web developers. A lot of what they're looking for is to kind of study eyewitness testimony and driving and things like that, where things can happen. You're talking about maybe going to court and doing an eyewitness testimony, and maybe you really just didn't see what you thought you saw. What they found was the 1996 study. They studied the change in saccades, which is kind of the eye movements and blinking and things like that. And what they found was that 20% of an image can change without you noticing. Another really good example of that is this. If you remember these old spot the differences pictures, it's a really good example of why humans are really bad at doing QA visually. Like expecting, just every front-end engineer to notice every little change that happens on a site, especially when other people are working on something, is is kind of silly. So today I want to talk a little bit about the tools behind PhantomCSS and what it can do for your development process. So PhantomCSS is built by a company called Huddle, and it's essentially a wrapper around 3 distinct libraries. The first is PhantomJS, which is kind of where the name PhantomCSS comes from. So you can either use, with PhantomCSS, you can either use PhantomJS, which is a headless version of WebKit, which runs in Chrome, or Slimer.js, which is the Gecko engine for Firefox. So you can kind of swap these in and out as you test. Casper.js is a navigation, scripting, and testing utility, which allows you to kind of navigate through the DOM and hover things and all that. And then Resemble.js is going to take the images that Casper captures and then compare them against each other and let you know if there are visual changes. I like to use Grunt personally. You can use Gulp or whatever. Grunt, there's a plugin by a guy named Micah Godbolt who maintains a basically just Grunt port of PhantomCSS. So you can integrate it with your general flow. So the implementation, let's start by setting up Grunt. So you're going to go, change directories into the path to your project, npm install. There's a namespace on this one. There's actually an older version of Grunt PhantomCSS that is no longer maintained. Micah has kind of picked up the mantle on that and continues to maintain it as changes are made to the parent library. So we want to load our PhantomCSS task, and then we want to, in our Grunt config, define the PhantomCSS task, and then say, I break it down by kind of the breakpoints that I use, and so we'll call this one desktop, and then you can define where the screenshot goes, where the results go, what the viewport size is, and then the source files for your tests. You'll notice that we start with a start.js file and then go to a wildcard file, wildcard that basically just runs through the rest of them. The reason we start with a start.js file is because Casper needs to start. So you call casper.start, which spins up the browser and everything, and then you can run through the rest of your tests alphabetically. So within the options, we can go and change, these are the options. So we can change the mismatch tolerance. The reason there's a mismatch tolerance is because I use a Mac. Some of the people on my team use Windows. Some of them use Linux. Every machine is going to render things slightly differently within kind of subpixel anti-aliasing and things like that. So for example, if I have a custom font that renders on my Chrome on a Mac, it may render slightly differently due to subpixel anti-aliasing on a Windows machine and differently on a Linux machine. So we want to add a little bit of mismatch tolerance so that we can avoid false positives for things that really aren't bugs. And then you can define, the root URL where you're going to be running these tests. I like to use sassmq for basically keeping an inventory of all of my breakpoints on the front end. So this gives me basically a menu that I can use to test against. So, whether you have just these that are mobile, tablet, desktop, and wide, or you have various other ones, you can basically go back to your table of contents and see where you need to target with your tests. So again, I showed you the desktop testing. You can add in, mobile and then define a different folder where that goes. And then that allows you to break up where each of these tests and different breakpoints are stored. And then you can see that the result is a demo that I put together. You can see the desktop one rendered the top one, and then the mobile test rendered below. So let's write our first test. Again, we start with a start.js file. We call phantom.casperTest equals true. It's a flag that if you don't put that in there, it's going to throw some errors. So then we call casper.start, which spins up our headless browser and our scripting utility, and then allows us to continue on. And again, just to point out where this came from. Then I like to break up my tests by components. So let's call this one header test. I have Casper.thenOpen, so at the top of each of my test files, I tell Casper where the next page is, which is what I'm going to be testing with this. So whether your component is on multiple pages or just one, you can pick where to test it at. Then you call Casper.thenOpen.then, which basically is just the next thing down. And then Phantom.CSS or PhantomCSS.screenshot. Again, you're telling Casper to take a screenshot of this file. The first argument there is either the class or the ID of whatever you're testing, and then the second is going to be whatever the file is called. So I call this one exactly whatever my component is called. And again, just to kind of dive a little bit deeper into test structure, focus on components. I think it's the best way to test your site because you know, as you keep breaking things into more modular components, you can just, you know, tag those tests on there with them. So, for example, a React project, you have your assets, you have your components in a folder called header.js, then you have your layout, you have your SAS file for that header, and then you have a test file for that header. So it's a really nice way of keeping things really straightforward and semantic so that, again, as you have a distributed project, you can test it, and then the next person up on that project knows what you're doing. And again, I mentioned that with Casper, we can script interactions. Casper.js, again, docs.casperjs.org provides a lot more information about the API available to you. Some of the things that you can do with this is Casper.click, where you can click on a button and take a screenshot of an active state, or download. You can see if your download works properly. You can fill in a form with .fill. You can scroll to a certain spot on the page, reload, or any sort of mouse event that is available. So for example, we can say Casper.then, this mouse move to the button, and then we'll take a screenshot of a hover state on that button. I'm going a little fast, so feel free to maybe interrupt me if you have questions. So in our start file, we can do other things besides calling Casper start. So if you're going to be testing something that requires a logged in state, I like to add that to my start file because PhantomCSS is going to run all of your test files in that wildcard-test.js in alphabetical order. So for example, if you're testing something in admin, but then you add something that maybe starts with 2 A's, but you're trying to test a login state, that's not going to work because that session is not going to be available. So what I like to do is if I'm going to be testing any sort of logged in state, I like to do that in my start file so that session is available for the rest of the test. And then we'll run our tests. So we can either do grunt PhantomCSS because that's the task that we defined, which will then run this. So we can see, I use a tool called time grunt, which allows me to kind of see how long everything takes. So for example, Casper or Phantom spins up, it takes all of these screenshots on the mobile side, saves them there, and then it says done without errors, and it tells me how long it took to run, which was 13 seconds. Most of that is going to be spinning up your headless browser. And then it saves the files to baselines. So we see we have our homepage test, which is different than the header test, but for this demo I used homepage, which is not necessarily a component, so I'm kind of only breaking my only rule here. So it saves our baselines to a folder, which we can drill into and see that we have desktop and a mobile folder. So our baselines are nicely spaced apart and very focused. And then inside there we have post.png, which is our post. But what happens if you fail a test? Here we see there was a change. So it ran through the site. It said no changes found for screenshots, 0 through 3. They're using the computer science numbers as well. And then, so the test failed. There was a 15.82% mismatch, and this one took 16 seconds. So we can see that the results there, now we have which components failed. So this was initially what I showed you with the desktop and mobile size screenshots. we can see that there was a change in banner 1 and footer 4. And this is what it looks like. So whenever we get our result, it's going to say, you know, the font size changed. I used a large background image on this so that you could kind of see how sensitive the differences are. So it's going to see that there's, because it compares pixel by pixel rather than just kind of, you know, looking at the whole thing. So it'll notice things that are even on busy backgrounds or things like that. Visual regression testing tools are not perfect. Again, I mentioned earlier about the different machines rendering things slightly differently. There are some other challenges with this as well. And these challenges are not totally solved all of the time. So this is one of those areas where once you get in here and you start working on you know, a test suite, a visual regression testing suite, you're going to run into some issues. And some of the common issues and some of the more difficult issues that I've run into so far is dynamic content. So, for example, so dynamic content. You're going to test an article page, and the content is going to change. The image is going to change. The title is going to change. The content of the article is going to change. So the way that we've solved this is by dynamic replacement. So we have a JSON object, essentially, that we store in our repo that we then have a what amounts to a class, that goes through and replaces all of that content with static content before it takes the screenshot. So for example, if your post title is "this is a title," and then you change it to "this is another title," this is going to use a known quantity title that allows you to compare apples to apples as opposed to being worried about, well, this is a false positive because the article changed, and that's expected. So what we do is basically we store this JSON object in our repo, so everyone has access to the same content. We go through, we replace each of these individual things with a known string or whatever. So here is kind of how in your test file you would do that. So you require the faker, you get the posts out of core, and then the faker, you instantiate it, and then you open, and I'll show you this core.getSite URL soon, and then you evaluate. So then you go through and you run the faker and you replace all of the content, and then you take your screenshots. So we're testing hero text, and we're replacing that with hero post, or we're calling that hero post. Another great way of getting around this is with style guides. So if you have a style guide internally, you can regression test that instead, because that shouldn't change content-wise. You should be able to, you know, ideally your style guide is going to pull styles directly from your site and put those into a style guide, and then you can regression test that. It's not going to get some of the nuances of the layout, but it's going to take care of most of the changes within components. I'm a big fan of a tool called MDCSS, which was built by a previous coworker of mine, which allows you to basically write your style guide inline in your SAS file and then generate a style guide off of that. So you can, you know, you call this one title, base CSS is the section, and then you write a description of what it is, and then you write an example of the HTML that is output. So, and then at the end of it, it's going to look just like this. Which I think is a great way of kind of putting together a style guide, because then your code is still your code, but the style guide is generated for you. There's a lot of overhead with this approach. It's going to require kind of a shift away from what you're used to with maybe just throwing up this is my home file and here's all my homepage styles. But I think it's a worthwhile shift if you need a style guide. Animations in web fonts. Again, I've mentioned a couple of times the difficulties with web fonts, but I haven't mentioned the animations. So PhantomCSS is really not going to do a very good job of testing animations because it's going to test it one time. So it's not going to be able to see kind of the life of that animation and then compare it against the life of another animation. So if you're using a site that leverages a lot of animation, this can be a really tricky process. And to be honest with you, I really am not sure yet of what the answer to testing animation is. You could maybe test it multiple times, add a pause, and then test it again. But that could, again, kind of lead to mixed results. Distribution, I mentioned earlier, I work with a distributed team. If you work with other people, then there's probably going to be some differences in your environment. For example, not everyone is going to have the same local URL. You may use Vagrant, I may use something else. And so maybe my local URL is mysite.dev and yours is hissite.dev. So to get around this, actually credit to a coworker of mine, Zach, who's here today, on how to do this. So basically you can define a local URL, save it as an option within Grunt, and then later on as you run your tests, it will check to see if that file is there. So basically when you run it with a flag that says test URL, it'll save that file with basically just where your local URL is. And then later on, it'll check to see if it's there, and if not, it'll use a fallback. So for example, we require the file system because we need to read to see if that file is there, and then we require the site URL out of there. So if you try to see if the file system can read that file, and if not, you have a fallback. So my fallback is local.wordpress.dev, and if that's where my site is, great. If not, then we can do that without really having, you don't check the local URL into the repo, you can change that. And everyone can have their own local copy of it. So then, in our test file, we say casper.then open site URL, and then the path to wherever you're testing, which is a great way of getting around that. Not everyone uses the same operating system. I touched on this a couple of times now with fonts. Fonts are going to change slightly depending on where they're rendered. So mismatch tolerance is going to take care of that. The great thing about this is because it's command line based, you can integrate it really easily with whether you're using Jenkins or Circle CI or Travis or something else. So you can set it up so that whenever you commit to your staging branch, it automatically runs your regression tests and lets you know it'll fail the build if you want it to. It can be a little frustrating because of some of the little nuances that I've kind of touched on here in the last few minutes. So it may be a little frustrating in a continuous integration build, but I think it's worth kind of sussing out some of those difficulties. Selenium, Stacy mentioned that earlier. If you need full browser compatibility, again, I mentioned you get WebKit and you get Gecko with PhantomCSS. If you need to test Edge and Internet Explorer and Opera and some of the other browsers and things like that, Selenium is going to be the way to go. I found it to be a little bit cumbersome just to get started with. I was a really big fan of the semantic nature of the way that PhantomCSS tests are written. You can write them similarly with Selenium, but again, I found it I didn't really need that level of detail with what I was doing. I just kind of needed to be alerted if anything changed so that I could check it out. So I highly recommend if you need Edge or Internet Explorer testing to use Selenium. Caution, it's a work in progress. These tools are kind of ever changing. Visual regression testing has been around for years, but it's still not been solved. There are several other challenges that I haven't even mentioned today that I maybe don't even know about that you will run into. So I think approach it with a let's see if this works for us, and if not, great. But I think it's a really great way to kind of build yourself a safety net so that your front-end engineers can work really quickly and quickly iterate and then get through things and just kind of make sure that their QA is really on point. So I don't think it's a replacement for manual QA. I think there's still an element there where you want to just double check what your automated testing tools are doing. But I think it's a great way to build a little bit of a safety net. Cool.